Right. Good afternoon, everyone. I welcome you to this wonderful platform. This is the Mental Hampir Kliman. Today we shall be looking at dimensional analysis questions that actually came from a past paper. So it's very important to go through these particular questions with me. You see how you would be able to answer this particular quiz questions we gave at Etsy Learning Academy. It's very important you really understand dimensional analysis questions and how to go about them. And of course, if you are new to the channel, consider subscribing, hitting the like button, and also don't forget to share to others. Now, the first question was actually saying we state the dimensions of the following quantities in MLT concept. So the first one we're given is actually for the force. Now we know that force is actually equal to ma, where m is the mass and a is simply the acceleration. The dimensions of mass is simply capital letter M, and then the dimensions of acceleration is simply, because acceleration is in meters per second squared, this is just the same as your meter is represented by L, and then of course your second is simply t to the power 2. So if you are to combine this, you are simply saying force is equal to, you will put your big letter M, where there is the mass, and then you're going to put your L, then t to the power 2. So if you are to find the dimensions of force in MLT concept, it's going to be M, L, then t to the power negative 2. Okay? You have written in MLT concept the dimensions of force. We go to density. So we know that density is actually equal to mass over the volume. The dimensions of mass is simply capital letter M. The dimensions of the volume, because volume is simply L times B, the base has capital letter L as its dimension, as well as the length. So volume, remember, volume is equal to L times B times H. So it's going to be L to the power 3. So this is going to be, you put your capital letter M on top, and then over, this is going to be L to the power 3. Then if you want to put it in a straight line, in MLT concept, this becomes your M, this becomes your L to the power negative 3. This becomes your answer for this particular question. And we go to C. Okay? We go to C. C is actually saying pressure. Pressure is equal to force over area. Now remember that area has its formula as L times B. So meaning the dimensions of area is simply L to the power 2. So pressure is equal to, what are the dimensions of force? It is simply M, L, T to the power negative 2. All over by, then area is simply L to the power 2. So this and that will cancel. So your pressure is going to equal to M, L to the power negative 1, T to the power negative 2. This becomes your dimensions of pressure in MLT concept. We go to D, which is simply the surface tension, because we know that surface tension is equal to your force over your length, which is just the same as M, because we know that force is ML, then T to the power negative 2. All over by, then L. What are the dimensions of length? It is simply length. So when you cancel this guy and the other guy, your dimensions of surface tension should be your M, T to the power negative 2. Then you actually be able to find the answer for this particular question. When you go to E, E is basically the energy. Now remember that energy is actually measured in joules. Then a joule has got the units kg, meters to the power 2, per second to the power 2. How do you go about writing its dimensions? The kg is the mass, so you would want to put your capital letter M. Your M is simply your meter, so you're going to include your length to the power 2. Then your S is simply your second, represented by capital letter T, then -2. This becomes your units, your dimensions for energy. And then you are able to solve everything that you need. Okay, we go to the second part. Now, the second part was actually saying we prove if the following formulas are dimensionally correct. Okay, so we shall be using dimensional analysis to prove whether a particular formula holds or whether it doesn't. So here is how you go about this particular question. The first one is simply displacement. S is equal to, then you have initial velocity, which is t, initial velocity multiplied by some time t, then they say plus 1/2, then at to the power 2. Now, we know that 1/2 is dimensionless. What are the dimensions of your displacement? It is simply capital letter L. So we say this is going to be our left-hand side. So on our left-hand side, we have capital letter L. Let's go to the right-hand side. What do we have on our right-hand side? So on our right-hand side, we can just cancel out this. Then what you're going to have is your ut. So the dimensions of u is basically the initial velocity, which is just L over t. So basically we are going to have your L over t. Dimensions of time is simply capital letter T, plus the dimensions of acceleration is something we already know, which is L over t to the power 2, and then multiplied by time, which is simply period to the power 2. So basically you cancel out this and that is going to cancel. Then you're going to remain with L plus L, which will give you 2L. Now you're going to have your left hand side having L, your right hand side is going to be having 2L. What did I say could be the conclusion for this particular question? The conclusion is this formula is dimensionally correct, but physically incorrect. It is dimensionally correct, but physically incorrect. Okay, so that's how we solve that particular question. Let's try to do more questions. We see how best we are able to solve these particular questions using MLT concept. Okay, so let's just continue rubbing the board and then we solve as many questions as we can. The second question is actually asking us to find this particular question. So we have v power 2 is equal to the initial velocity power 2 plus 2ax. What are the dimensions of velocity? So we're going to say left hand side. So on the left hand side, we know that the dimensions of velocity the power 2. So we're just going to have our L over t power 2, which is going to be L to the power 2 over t to the power 2. And then we go on the right, we see what we're going to have. We can say right hand side. Right hand side, we are going to have L over t Okay, this power 2, plus, then the 2, of course, is out, and then we are going to have our acceleration, which is going to be L over t power 2. Then we're going to be multiplying by our L. So basically, this is going to be L, sorry. This is going to be L to the power 2 over t to the power 2 plus L to the power 2 over t to the power 2. Then everything, we're going to have a t to the power 2, this into that. Or basically, this is going to be L to the power 2. And then we're going to factor out our 2, and then L to the power 2 over t to the power 2. Now, basically, what we're just going to have is something which is going to look like this. L to the power 2 over t to the power 2 is equal to 2, then open bracket, L to the power 2 over t to the power 2. Now, notice that this particular end and the other end are the same, except we just have a 2 factored outside. So we say that this formula, okay, this formula is dimensionally correct, but physically wrong or incorrect. So this is how you solve this particular question. It's actually very, very simple. Let's try to solve more questions. We try to enjoy as many questions as we can on dimensional analysis. It's actually very simple. If you're finding these lessons very tricky and you would want help, make sure you register for personal tuitions on a number I'll put on the screen, which is +26 0777 66 40 46. You text on WhatsApp and I'll be able to respond to you. We go to the next question. The next question is actually given as the period is equal to 2 pi. Then they say the square root of L over G. Now, remember that 2 pi is dimensionally, it's actually a constant. It doesn't have its dimensions. So it's something that you are going to ignore. Now, remember that the dimensions of period is simply the same capital letter T. So your left-hand side is basically a T. Now, let's try to do our right-hand side. We see if we are going to have the same. So we are going to square this. What are the dimensions of length? It is simply capital letter L. Now we find the dimensions of gravitational field force, because we know that gravitational field force has its dimensions of L over T to the power 2, which is just the same as L over L multiplied by, okay, so the T goes on top. Okay, so the T is going to go on top. So this is going to be, if T goes on top, it's going to be T to the power 2. Then the L comes in the denominator. This becomes 1. You cancel, you're going to have the square root of T to the power 2, which is just T. So your right-hand side is going to be T. Your left-hand side will be T. Now, what do you have to say about this formula? It is simply dimensionally correct. Dimensionally correct. And that is how you get this particular question correct. Now, if you're finding these interesting and helpful, make sure that you answer this particular question and this particular question, and then make sure that you send them to the WhatsApp number that was put on the screen. Let's go further. We see if we can actually do the last question. We have question 3, which was actually saying the force F acting on an object depends on its mass m, then its velocity and radius r, according to the equation given. Okay, so we have this particular equation In the equation, we've been given the force, so we're going to find the dimensions of each quantity given. What are the dimensions of force? The dimensions of force, of course, we had mentioned that in MLT concept. Okay, let's just try to come up with it. So it's going to be MA. Then, of course, the mass is capital letter M. So this is going to be capital letter M. Then A is simply L over T power 2. So the force is going to have the dimensions of M, L, T to the power negative 2. Then we come, so let me just try to put it here because I'm going to use this space for my calculations. Physics is actually very interesting and helpful, especially in solving problems that have to do with engineering. And that's the reason as to why we actually giving you this basic information. What are the dimensions of velocity? The dimensions of velocity is simply L over T. Okay, so velocity in MLT concept is going to be L T. Okay, like that to the power negative 1. Right. Then what are the dimensions? What else have we been given? We've been given the radius. Now the radius is simply r. Okay, dimensions of r or radius is gonna be your L. Right, so this is going to be L. Now let's try to come up with something. So basically what is going to happen here is this. We have the formula force is equal to, because the K there is simply a constant. Let me see. So okay, let's also find the dimensions of M, which is mass. Don't forget capital letter M. So now everything in MLT concept. So the formula given is simply, you forget the K. So it's going to be M to the power A, V to the power B, R to the power C. So let me get the dimensions of force. So the dimensions of force is simply M, L, this is M to the power 1, this is L to the power 1, then T to the power negative 2. Then I'm going to get everything. So this is going to be the mass. So it's going to be M to the power A. It's actually very simple. The velocity, it's going to be LT to the power negative 1 to the power B. Then the radius, which is L, to the power C. Now let me make equations. So I'm going to start with my A. So I'm starting with my M. It's going to be M to the power 1, then equal to, then I multiply everything having M. This is going to be my A. So of course you cancel the bases. Your A is going to equal to 1. Actually very simple. You just have to, you cancel, you already have your answer. So you go to the second one. If I'm using L to formulate an equation, which is L to the power 1, then I have to multiply all the L's on the other end, which is going to give me L. I maintain the base. Now because I'm multiplying B, this L is, this B is multiplying the power 1. This is multiplying the power 1 here. This is going to be B plus C. So you cancel out, you're going to have your 1 is equal to B plus C. This can become your equation, second equation. Let's find this third one. We are using T. So for the third one, it's going to be T to the power negative 2 is equal to, let me check how many T's I have. You notice that I only have one T here. So this is going to be T to the power negative B. So you cancel out this, you cancel out this. You're going to have negative 2 is equal to negative B. And you cancel over negative 1. Over negative 1, your B is going to equal to just 2. Now you can actually find C because you're going to have 1 is equal to your B plus C. 1 is equal to, what is B? B is simply 2 plus C. So it's going to be 1 minus 2 equal to c. And then your c is going to equal to -1. And this is basically how you solve these particular questions. If you found this video interesting and helpful, consider subscribing, hitting the like button, and also don't forget to share to others. Thank you so much.